right, let's talk about trig functions and using them to solve real-world problems. Now, one of the things that you really want to keep in mind whenever you're solving a trig problem like this is that you're looking to draw a triangle. So let's look at this example. It says an escalator at an aquarium is used to transport passengers a vertical distance of 36 feet to the second floor. Okay, so we could spend lots of time drawing like the fishies or whatever. That's supposed to be a fish. This one's a octopus. But the important piece is we've got an escalator. Now, escalators are those moving stair things, and it's going up. It says 36 feet vertical distance. So vertical is up and down. So we know that that's talking about this side being 36 feet. That's the important piece. Okay. Now, if it's going up and down, straight up and down with the ground, forms a right angle. It says the escalator makes a 20-degree angle with the first floor. So we know this is 20 degrees. How long is the escalator? Now, the escalator, that's actually the part, that has the stairs on it. Something like that. So we're actually trying to find this part. We're going to call it x. Now, if I look at this triangle, because the important piece of this whole drawing is just the triangle. And I think about what sides I know in relationship to this reference angle. I know right across from the right angle is the hypotenuse. And I know across from my reference angle is the opposite leg. So if I look at TOA, I have the opposite in the hypotenuse, which is right here. So I know sine. So sine of 20 degrees is equal to the opposite, which is 36, over the hypotenuse, which is x. And now we're just doing a trig function problem. So I'm going to go ahead and put this over 1 so I can cross multiply and solve. 1 times 36 is 36. Sine of 20 times x is sine of 20 times x. In order to get x by itself, I need to divide by the sine of 20. I need to divide by the sine of 20. So that'll cancel, and this will give us our answer. We're going to have to plug that into a calculator. And I'll have more space over here. So 36 divided by the sine of 20. Also want to double check that my calculator is in degree mode. We see that in the upper right-hand corner of the calculator screen that it is. We'll go ahead and hit enter. And 105.25. Let's see, rounding to the nearest hundredth. So that's 2 digits. So 105.256. The 6 will make the 5 round up. 105.26. That's how long the escalator is. All right, let's look at this one. It says a grain elevator, there are conveyor belts used throughout the Midwest to transport grain like corn to the top of a grain bin for storage. Okay, so basically what the grain elevator looks like is it's kind of like a conveyor belt thing, and it's got a bunch of buckets on it. Something like this. And there's usually like a little tractor thing running it. There's the tractor, and it's full of grain in these little buckets. And as they get to the top, all the grain falls into the grain bin for storage. And then we can have like grain for the future. And yay, we get to eat grain like corn in the future. All right. So that's the general idea of what's happening. Now it says if the conveyor belt makes a 55-degree angle with the ground, so that means we know right here, we're going to call this and the ground 55 degrees. And it says the conveyor belt is 5 yards long. That's 5 yards. Which trigonometric equation could be used to find how far the base of the conveyor belt is from the grain bin? So if we want to look at this conveyor belt, we need to think about the triangle that we have right here, written in red with a right angle. Now, in relationship to my reference angle, this side right here, well, that's going to give me my hypotenuse. Oop, I don't know why I wrote natural log of y. Hypotenuse. And we want to find how far the base of the conveyor belt is from the grain bin. So that's this distance right here. That's going to give us our x value. Okay, now in relationship to that, that's adjacent. So, we have the adjacent side, we have the hypotenuse, adjacent and hypotenuse, that's dealing with cosine. Now, which one of these set that up right? Adjacent is x, and it's adjacent over hypotenuse, which means this is our answer. Okay, there's a follow-up question. How far is the base of the conveyor belt from the grain bin? Please use the exact ratio to calculate the missing side. Round your answer to the nearest hundredth. Okay, so we need to solve this ratio. So cosine of 55 equals x over 5. Cross multiply. X equals 5 times the cosine of 55. Let's ask our calculator what that is. 5 times the cosine of 55. That's going to be 2.867. The 7 will make the 6 round up, so 2.87. There you go. Okay, let's look at this next example. It says a ramp is propped against the back of a truck and forms a 27-degree angle with the pavement. So let me draw my truck real quick. And we've got a ramp coming off the back. This is forming a 27-degree angle. The back of the truck is 3 feet above the ground. So we know this is 3 feet. Which trigonometric equation can be used to find the length of the ramp? So we're trying to find x. Now, looking at this, I have the hypotenuse is what I'm going to try and solve for. And what's across from the 27 degrees? Well, that is the opposite side. So which trig function? So TOA are we going to use in order to solve this? When we have opposite and hypotenuse, we need sine. So now I'm dealing with sine. Now, opposite over hypotenuse, opposite is 3 over x. Hey, that's this one. Now, in order to solve this, we're actually going to have to solve that equation. So sine of 27 equals 3 over x. Now, in order to solve this, I'm going to divide by 1, which doesn't change anything, and then I'll cross multiply. 3 times 1 gives me 3. Was the sine of 27 times x. Let's divide each side by sine of 27. That'll cancel, and then we'll get a value for x. Round is to the nearest hundredth. 3 divided by the sine of 27. That's going to give me 6.608. The 8 will make the 0 round up, so we're going to have 6.61. Let's do one final example. Elmer is flying a kite, with a string that makes a 58-degree angle with the ground. If the kite string is 22 meters long, how high is the kite above the ground? Okay, so let's go ahead and draw Elmer. I think Elmer's going to wear a hat, and he's flying a kite. Looks something like that. Now, it says here that his kite is making a 58-degree angle with the ground. It says his string is 22 meters long, and it's asking us how high is the kite above the ground. So if the ground is down here, then how high? That's x. All right, which trig function are we going to use to solve this? Well, right here, I know this is my hypotenuse because it's across from my right angle. And right here, this is my opposite side because it's across from my reference angle. Opposite and hypotenuse means sine. So the sine of 58 degrees is equal to opposite over hypotenuse, which is x over 22. Then I'll go ahead and divide by 1 so I can cross multiply and solve. 1 times x gives me x. Sine of 58 times 22 will give me my answer. Which is going to give me, round to the nearest hundredth. The 7 will make the 5 round up. X was equal to, oh, I already forgot what it said. 18.66. That's how high the kite is above the ground.